Thank you, Maurizio, for this enlightening talk, giving us all the gory details of using formal foundations for conceptual modeling. I guess that many people appreciated that. So we start now the question and answering session. There are already a number of published questions, but I'd like to do a couple of questions myself as a warm-up. So you did start your research work by having your first publication at an ER conference in 1981. This was 39 years ago, right? And you mentioned that Battini was your supervisor, inspired you in doing research in conceptual modeling, and I've seen basically you have published at the ER conference in 81, 83, 85, 88. So this was a very rich decade for you, and really ended up in this what I believe is a seminal paper that really gave the formal foundation to ER modeling that I consider myself really interesting at the time. What really led you to do this kind of research? So why, how could you even imagine that you could give a logic-based foundation to conceptual modeling at the time, so 40 years ago?
Okay, that's a very good question from my personal story. So at that time, I didn't know logic. I didn't know, I just thought the logic was the tool for expressing condition in programming, because I was fond of programming. So I actually published my first book on assembler. So I was fond of programming. So for me, logic was just and, or, and not in the if instruction of programming languages. But then, at a certain time when we were discussing with Carlo Battini about, modeling databases, I still remember the following fact. I said, but what about, why can I cannot introduce an entity that denotes the person who are old? So I wanted to introduce a new entity in my entity relationship model, but with the specific semantics. They say it's not just a subset. I would like to express the fact that this entity is exactly the set of persons that are old, where old means that age is greater than, at that time, 50, because I thought that more than 50 was old. Now I would say more than 80 or 90, okay? So I wanted to introduce in the entity relationship model a defined class. And this was my, my first idea of what, and Carlo Battini says, but you cannot do that. And I was not satisfied with the answer. I mean, well, so I asked myself, what do I want really to do? And then I started, and I don't know exactly who, but someone talks about formal logic, first order logic, and then I started studying first order logic, and I said, okay, come on, a defined entity is just an entity that satisfies certain assertions in logic. Now that was my first, idea of. I was not happy with just the intuitive semantics of the entity relationship schemas, because to me it was a too weak, tool in order to do some more interesting stuff in the entity relationship schema, and therefore also in the database that after that. So that's the starting point. That's why I became interested in trying to go beyond the informal semantics and say, well, that's a table. Well, I know it will be a table, but maybe there is something more.
That's interesting. So, but at the same moment, in parallel, we had the seminal paper by Brachmann-Levesque in 1984 on the first description logic formalized in logic. So were you aware of these results? Or?
No, I wasn't. I wasn't aware, because what I really did was to read a wonderful paper by Ray Reiter in the book of conceptual model. Come on, the Bible of conceptual model. It's a book by John Milopoulos on conceptual modeling. Okay, that's a Bible for me. And indeed, in that book there was a wonderful paper by Ray Reiter talking about the databases and logic. And this is really opened my mind toward the real could I really use logic in conceptual modeling, okay? But then I decided to follow John Milopoulos when I won a grant to spend 1 year in a university abroad at that time. It was something like a CNR grant that I got. And I decided to do what? To go to John Milopoulos, because I knew that he was the author of my Bible. And therefore I decided to go to Toronto. The ironic thing is that I went to Toronto in 1986, and John Milopoulos had a sabbatical year in Europe in 1986. So I went there, and John Milopoulos was leaving Toronto, but I met Hector Levesque, and a new word was open. Again, a new word open in my mind, because Hector Levesque was with Ray Reiter at the time in Toronto. And then I started really, studying semantic networks and all the logical stuff behind AI.
Yeah, I also believe that the On-Conceptual Modeling book is really a Bible, and it still contains a lot of wisdom that most of us needs to elaborate and digest. So this means that since then you have used logic in many different works. So you have done works in services, semi-structured data integration, and you always use logic as the formal foundation for this. But all these different areas of, say, AI, what can you tell us if there is a thread, a common thought among all these works, because they look somehow quite disjoint in terms of focus, but I'm quite sure that you had something in mind while developing all these different ideas along your career.
No, I mean, so I really, spending 1 year in Toronto, I studied many different things, and I realized that logic is not just a single system, right? There's more. I studied modal logic there. I studied dynamic logic there. I studied a lot of things there, and I think that the unifying thread is syntax and semantics. So it's a very stupid thing. Logic is a great, if you want to understand that a language has a syntax and a semantics. And the semantics is disjoint from the syntax. So all these kind of things, all these kind of application that I tried to apply in my career, that the unifying thread was, I'm fond of logic, and I think that this distinction between syntax and semantics, between proof theoretic and model theoretic, that that paper of Ray Reiter taught me about, that's the unifying thread.
So you have to know that while you were in Toronto, I was doing my thesis in Rome, and at the place where John was actually a guest. So I've learned in '86 all the work from Brachman Levesque and the On-Conceptual Modeling book by John himself. So this is quite funny. So if we change decade, I remember at a workshop in, I guess in Cambridge, Massachusetts, and AAAI workshop on description logics, that connects with what you were saying before, that you are fond of programming. So you are a theoretician, you are a logic guy, but I remember that there was at the time this sort of your harsh comment against people at the workshop that were saying that we needed to have description logic pure. We don't really like the notion of multiple inheritance. We don't really like the idea of connecting with the object orientation word. And you were saying, no, we should be connected with the object orientation word. We should be connected. We should understand multiple inheritance and how real software engineering works, because this is computer science. We are not just logicians. Do you remember that?
I do, but maybe not exactly the comment, but I agree with your comment about I still think that we should do a lot of things that we are not doing. Like, for example, okay, if you could reconsider my slide saying that my dream in my career is to use a conceptual schema at runtime. Why not programming over the ontology? That's another. So I'm too old, right? I cannot do all the research that I was dreaming to do. But if I was young at this moment, this could be a very nice research program. Why couldn't we just not only connect our ontology to data, right, by means of mapping, but also trying to program our system through the ontology, right? So not just go, because right now in the ontology-based data management system paradigm, if you want to program the data sources, for example, writing a microservice over the data, you do it over the data, right? But so why not inventing a language that expresses your service, your process over the ontology? So I still think that looking at the real problems in software engineering and trying to apply our ideas of, logic, formalization, there it might be a very nice and interesting stuff. But in order to do that, you have to understand the applications. You cannot say, no, there is no multiple inheritance, right? Because people want to use it, and therefore you should be good. I'm not too good in order to solve this problem, but I hope other people will do it. Okay, I mean they are very, very complex problems, right? But I think it's a nice research problem.
Thank you for this very wise answer. Of course, you are not just a logician like you just said, and so much not that you also have started a startup that is quite successful on ontology-based data management. Can you tell something more about this endeavor that you are doing now with this startup?
First of all, I'm sufficiently old to tell you the truth. It's not very successful, in the sense that we are really, trying to apply our ideas in the real world, in particular in public administration, because I think that the most important potential for this paradigm is in public administration, or at least I would dream of, contributing to my country in improving the information systems of public administration. And to me, this means, for example, trying to apply the ontology-based data management paradigm, because on top, I give you really two words why I think that. In many cases, public administrations in Italy have a huge problem. They do not possess the property of knowledge that they have. So the knowledge of public administration is given to the companies that win the competitions and build the system. The public administration do not have the knowledge of they do not possess their knowledge. There is a lot of knowledge behind the systems of public administrations, but all this knowledge is hidden in the applications of the companies that win the competitions, right? And I'm really, disappointed by the fact that these companies are 5 or 6. I'm not going to tell you the name, but you know that. So all the knowledge about our public administration is hidden in applications managed by 6 companies. And these 6 companies do not really want to improve their information systems because they somehow govern the market. So the result of this is that public administrations do not really possess the knowledge. They cannot really exploit all the knowledge they have because they do not know. I mean, it's hidden in the application. So that's why with my startup, my dream was trying to do projects in several public administrations and trying to tell them, look, you have to extract your knowledge from the applications and formalize it. You guys, not the, not the company. You have to formalize. You have to have workers that know how to design an ontology, and therefore you should also hire new guys in the public administrations with new competencies, with new modeling competencies. Now you have to model your knowledge in terms of the ontology of the public administration. So that was my dream with my startup. It's not, it's not like, becoming rich or then selling. I know that I will not sell my company to nobody, but the idea was that. And to be honest, in the last 2 years, we have 5 or 6 projects with public administration, essentially, and for example, ISTAT. And now we are starting to do it, and it's fun. It's really fun. And it's fun, but also I think useful, because at my age, I would like to really do something useful to my country. And I'm a poor, stupid, theoretical guy that I cannot do very big things, just ontology-based data management.
Very wise word, Maurizio. Now we go to the questions of the public. And I've seen that at least the first 4 or 5 questions, they are all related with this problem of expressivity. So the people are concerned whether the choice of using description logics may be a limit, or they're just a starting point to do something more. So I guess I just read the questions. So Evelyn is asking, we know that description logics are fragments of rest of the logics. If the domain has some constraint that cannot be expressed in the DL, how to deal with that? Constraints in the mappings, maybe in the services that access the DLs, not put those constraints?
I can give you my answer, okay? There might be many other answers. What I did to solve or to address this problem is to add constraints to description logic with specific language. What does it mean? It means that whereas the axioms of description logic allows you to derive new knowledge, they are not good. The axioms of description logic, they are not good to express constraints. For example, if you say that every student has a code as a matricola in Italy, right? As a student code. What is it? This might be an axiom, or it might be a constraint, right? When you write this axiom in description logic, this is a real axiom that allows you to infer new knowledge. For example, if I know that Enrico is a student, I know that he has a student code, right? But it does not express the constraints that I should know the code of Enrico. This is a constraint. So what I did to address the problem is to enrich the whole system with a constrained language at the level of the ontology, where you might express constraints that you want your data to be satisfied. Okay, so this means that although the computational obstacles does not allow you to add more axioms, more general axioms to description logics, you might recover this kind of knowledge by expressing constraints. And the good news is that if you consider constraints, you might use a more expressive language than, for example, the Enlightened, much more expressive language. to express more expressive conditions that will not be considered axioms in the system, but they will be considered integrity constraints. So that's one possible answer if I have understood the question.
Yeah, thanks. I guess that's the obvious answer, at least to me. The other answer by Bernard, the question by Bernard Thalheim, I believe, is now focused on the expressivity of query languages. So query language displayed so far is based on conjunctive queries. Can you extend all this to the set of queries which use stratified negation and well-defined typed connectives, the ones that properly map to typed operational algebra? SQL is often used with bugs or multi-set semantics. Can you extend the query foundation to bugs?
Not me, but there are people that are doing this. In fact, Gianluca Cima, for example, who I just mentioned before, is working exactly on query languages with bag semantics. But there are many other people, like Diego Calvanese in Bolzano and other people, trying to extend to bag semantics the work of query answer. But I agree with Bernard. I mean, there is a lot of room to try to capture more expressive query languages. Now, the problem is not easy, okay? It's not easy. So if a student is listening to us, they shouldn't think that, okay, I will go there and I will extend the query language. That this is going to be very hard. But there is room to do that. Group by, for example, okay? But all this new stuff combined with incomplete information that is implicit in ontology-based data management is going to be very hard. But, I mean, research obviously is also, it's a path towards more complex problems. So go ahead, guys. I'm too old to do that, but there is a lot of space to do that. From my point of view, what I have done is to introduce EQL, which is a query language extended to a particular form of negation or other constructs, by which I can capture some stratified negation. I think Bernard was talking about. But again, there is there is a space to do that. But please take into account that all of these should coexist with incomplete information that is implicit. But by the way, Enrico itself, I've gone through his slides, and he tried to do something. For example, what about a D-box? All right, this is a kind of trying to extend something, but he knows exactly that he has to exist with incomplete information also.
Thank you. Now, even going in a even more complex direction, and a question is about, you have been working also with higher order description logics. How would that impact with what you have presented today? That's a very nice question. Thank you. I think that there is a lot of nice potentialities to use abstraction with higher order description logics. Why? Because abstraction, remember, wants to express a service at the level of data. And if you have meta classes and higher order features in the language of description logics, you might be able to capture more semantics at the level of data. So I think that's a very nice question, and our plan is to see what happens if your language has higher order features, like, for example, high DL light. I mean, just a language specific to express meta classes and meta properties in description in DL light. Even this very simple extension might be very useful to get more abstractions, more powerful abstractions. So unfortunately, I'm very close to the
to the retirement, but who knows? Maybe I can have some result before my retirement.
Lucky guy, you are going to retire and have a happy life. So now we go back to history, so the other side of retirement. So this is a question about how did you have the idea of using description logics as opposed to alternatives based on logic to formalize ER diagrams? Because they say DLs are very focused on were very focused on taxonomic reasoning, and the original ER did not have at all taxonomic constructs in it. They were introduced later.
Because I met Hector Levesque, and I you know, at that time there was no, the word of description logic was not there. They were called terminological systems, and if you think about it, the terminological system is a very general term that says I have a terminology and I want to express the semantics of the terms. So I thought that was a very nice, and then I just understood exactly at that time that there was a natural evolution of semantic networks, right? And therefore it was a natural way to do, a natural way to go to the fathers of the AI formalisms and the logic-based formalism, and trying to use this in order to formalize the AI. That's it.
Okay.
Well, I could have used first-order logic, right? I could have used first-order logic, but I think description logic has a nice idea of adding the idea of taxonomic reasoning, which was, by the way, very, very important for ER, because there is a relation at that time. It was not there, but it's a very natural thing that we all human beings use, in formalizing and reasoning.
Well, at least in the form of foreign key, I guess. So a question about the practical side. Are there currently commercial systems for OBDA that are expressive and that can handle big data and large schemas?
Well, I think that this question is a bit, so the fact that you have a lot of data in your data sources is completely orthogonal with respect to the ontology-based data management specification, right? It's completely orthogonal. I mean, you might, because having a lot of data at the data sources might obviously suggest you to have a very good system to optimize the query, but it doesn't really impact on the idea of ontology-based data management. So if the question is, can we really use ontology-based data management system right now in order to access a lot of data? That's a good question, in the sense that we still have a lot of research to do in order to optimize the query that comes from the ontology, right? So there is a lot of optimization that we could still do. Is there any system for ontology-based data management using expressive description logics? No, I don't know of any of them. All of the ontology-based data management systems that I know use the description DL-Lite. I might not knowing all the systems, but all the systems that I know use DL-Lite. And I agree with the question. If this is the crux of the question, is that having a system that guarantees for every query of the ontology to rewrite it in the optimal way, that's a goal. It's not a reality. So we still have to do a lot of research in order to optimize queries.
Yep. Okay, Marco is asking, dear Maurizio, can you tell us more about the role of object constructors in the right-hand side of mappings, and how these relate to identification schemes in conceptual modeling? In addition, conceptually speaking, how do mappings relate to conceptual schemes? What do they reveal about the intentional characterization of the domain of interest? Can they even be considered as an integral part of it?
That's interesting questions. So I'm going to give you my view, okay? this might be a topic for discussion more than, you know, I give you the answer. So I really think that the ontology should be confused with the mapping, because a mapping really is tailored toward a particular data schema, and therefore I wouldn't consider the mapping as part of the conceptual, you know, schema of the domain. Now, that this is going to be very, very, very difficult to express. There is a question of what is the role of the system. Okay, the system itself is an object that you could model, right? Now, the ontology is modeling the universe of discourse. It's not modeling the system. So I would like to rephrase the question like this. Would it be useful to introduce in the ontology also the description of the system? Right? So if you want to describe the system, then the mapping is part of the description that you want to derive, right? Because the mapping is, you know, part of the system. So if you want to describe both the world, the outside world in your domain, and the system in the ontology, then that's an interesting question. So could, for example, which is in other words, the metadata of the system, right? Because if you think about it, a mapping could be, so the description of the mapping could be a metadata. A metadata in the sense that it's not the data of the system, but it's part of the documentation of the whole system, right? So in other words, if your information system is not just a set of data sources, but it includes also the mapping, you would like to describe the information systems, and therefore not only the domain of interest, the outside world, but also the mapping. What does the mapping reveals about our conceptual schema? Well, at design time, that's a very interesting question. At design time, you working on the mapping might reveal that your ontology is not completely appropriate, right? Because, for example, you might come up with the idea that you cannot map a part of your data to the concept, and so you might have, you know, an ontology which is incomplete with respect to the word that you would like to describe. Or you might also want you might derive the idea that you want to change the ontology because of the mapping, because of the data sources. But that's at design time. So I think that at design time, so for example, in my company, what we propose as a methodology is, first of all, to talk to people that are not technical staff, to derive the first idea of the ontology, describing the real concept in the real world. Then we work with the technical people dealing with the database and trying to understand the semantics of the tables or the data structures there, and then we do the mapping. Okay, and if you follow this methodology, actually most of the time you enter into a loop where you also modify the ontology, adjust the mapping, understand better the data sources. It's a nice loop, but at the end, so at design time, it's clear that working at the mapping can influence the ontology. At runtime, this is, to me, it's even more interesting. Should we document the mapping in the ontology or not? So should we use the ontology language also to document the mapping and therefore to enter into the knowledge of the system itself? That's a very interesting question that would really bring us to other very long discussions. I have I think very nice examples showing that if you follow this path, you have a lot of interesting stuff to think about.
Thank you. Now my co-host Giancarlo asks a question. Maurizio, thanks for the great talk. What about the issue of modality, which ontologically speaking is typically used to differentiate person on the one hand and employee and student on the other hand? What is the influence of what this kind of, say, temporal modality consideration for OBDA? What is there in terms of OBDA for temporally sensitive data that differentiate essential and accidental properties of entities?
Okay, that's another great
stuff.
That's another great question. So what I try to do in all my investigation on description logics is not only to understand all this concept of modality and you know the meta properties of concepts, but also trying to express it in the logic, because at the end of the story, at runtime, you would have an artifact. So the real question that I think we should address when we talk about these particular things is, how should I express in a formal language? It might be not the DLite, but another description logic or another language. What is the real impact of all these, you know, ontological questions into the language? I think that you know, introducing meta classes, higher order logic is a way to go, and that's why we thought we with Antonella Poggi, for example, we have studied the problem of you know, extending the DLite with meta classes and meta properties in order, for example, to say this class is rigid, right? So this class is rigid becomes now a new assertion in the description logics with all the implication that you might have. Now, ironically, or interestingly, the question of Giancarlo is very related to the one that I discussed, to the previous one. Because most of the time, these ontological properties like rigidity impact not very much on the static view of the ontology, but on the dynamic view of the ontology. So how the ontology evolves, right? And therefore, it's a very interesting stuff of asking which are the language features that allows me to bring at runtime all this knowledge that I have about rigidity and so on. And this is a very interesting question. We studied some of them, but there is a lot of room to study which kind of things at runtime should I use in order to be coherent with my ontological modeling.
Okay, thanks. Now we have Marcos coming back. An even more important question from my side related to programming over the ontology. This requires to attack the view update problem, right?
Absolutely correct. In fact, one work that we have done again with Antonella, Giuseppe, Diego is trying, for example, to express update over the ontology. So that's a first step, right? Because every program, in some sense, works with states, right? So, I want to, for example, to express a service that formalizes the idea that a student has finished his path, right, or his PhD program. Now I want to say Enrico graduated. So now what the point is, how should I change my system in order to reflect, this program. In other words, what should the system do in order to execute this program expressed at the ontological level? So the first thing you have to solve is the update problem. So it's a kind of view update problem, because if the mapping introduces views, right, and therefore updating the views should also impact on how do you want to change your data in terms of views. So again, this is a very interesting problem. I tried, I worked on that, but I know that I will retire without solving all the problems that I have studied. Okay.
Okay, then we have
just a little percentage. Just a little percentage.
So then Alessandro Mosca asks how to overcome the problem of badly documented open data sets if you want to do query abstraction and you need mappings. In my personal experience, I cannot agree more with your public administration related arguing. Thanks for having highlighted that to us.
Thank you. Well, this is one reason why I started thinking about query abstraction, because I wanted a general methodology to document open data with the concept of the ontology. And I wanted to do it automatically, right? Obviously, automatically doesn't mean magically. So the point is, you have to invest by designing the mapping. But once you have invested by designing the mapping, you have, with query abstraction, you have the possibility to document open data. And by the way, I didn't talk about this, but we are also working on this very nice and, to me, interesting problem. Suppose you have the output of a classifier, of a machine learning algorithm. You have the output that says, for example, I have the list of people that the bank has given a loan to. So Enrico is in the list, Giancarlo is in the list, Maurizio is in the list. Can I take this list and then, using query abstraction, to tell me which is the query over the ontology that captures this list of things? This might reveal that, the bank has given a loan only to white males, right? So in some sense, I'm dreaming of a query over the ontology which exactly captures the behavior of a classifier. So that's another kind of application that the notion of query abstraction might be useful for.
Okay, thanks. I guess you have the last question now by Zaida. So this, I guess it requires some explanation before. So it talks about Stafford Beer. I don't know whether you know him. Was a British researcher in cybernetics, and he actually did work on understanding and formalizing the management architecture, so what today would be called an enterprise ontology for Salvador Allende during the socialist government in Chile in the early 70s. And this effort was called Cyberscene. So this question says, you consider that the Stafford Beer Cyberscene during Salvador Allende time in Chile was a draft of a public administration ontology or an intended to build an ontology-based data management system? Do exist formal documents of this? Are you aware of anything about this?
Unfortunately, no, but that's a nice clue. I will look at it. I mean, I obviously love that part of the history, and therefore it's interesting to me. It's interesting to see what happened there then. So if I can see exactly the name of the
you can read all the questions in the Q&A.
Okay.
It's the last question in this case.
Good, thank you. I cannot answer, but I will look at it.
Okay, thanks, Maurizio. So this ends your seminar. This we had a very interesting Q&A session, I guess, and there were many interesting problems that you highlighted rather than solutions in the latest part. But this is what's exciting about research, because it's we are all here to advance the knowledge of the world, right? That's our job, and your job in particular as our head.
So thank you.
Okay.
Now I will go back to the 3 pillars.